In this video, I'll be talking about some basic classical properties of these particles, uh, alpha particles, beta particles, and gamma particles. And as we have seen that when we have an unstable nuclei, it undergoes emission of particle, it undergoes the decay, and during the decay, it emits particles, alpha, beta, and gamma. Now, talking about uh, alpha particle is basically it is He42, which has lost two of its electrons. So this alpha particle is equivalent to this helium 4n2, and this helium 4n2 is doubly ionized helium atom consisting of two protons and two neutrons. So to talk about the main properties of these alpha particles, is the very first property is that it has positive charge, and that charge is plus 2e. And as we know, the fundamental charge is 1.6 times 10 to the power of minus 19 coulombs. And they have a rest mass. Okay, they have rest mass, and that rest mass is equal to it's four times mass of a proton. Rest mass. Okay, so we can roughly say four times mass of proton. And the next important point is that they are emitted with velocities ranging from 1.4 to 10 to the power of 7 meter per second to 2.2 times 10 to the power of 7 meter per second. The next important property is that they are deflected by electric field, and they are deflected by magnetic field. The next important point is that when alpha particles fall on materials like uh, zinc sulfide, and other materials, what it causes, it can cause fluorescence. And and the next important property is that they have low penetrating power. Low penetrating power. And to talk about it roughly, if we have air of thickness 7 centimeters, this much of air can absorb alpha particles completely. And if we take an aluminum foil, Al aluminum foil of thickness 0.01 centimeters, it can penetrate this foil, this alpha particle. And the next important point is that they have high ionizing power. And we understand what's ionization: the power to eliminate electron from its shell out of atoms. So these alpha particles have high ionizing power. And to roughly talk about the power, what it does is it produces about 20,000 ion pairs per centimeter of air through which it passes. 20,000 ion pairs. Okay, and they certainly do affect photographic plate. They affect photographic plate, and and these alpha particles are capable of producing heating effects. They producing heating effects. Whatever they strike, so they produce heating effects. when they fall on any substance. And the next important point is that they can cause skin burns. They can burn the layers of skin. And the next important point is that these alpha particles, they are scattered. They are scattered. They are scattered by thin metallic plates. And finally, the distance through which these alpha particles can travel, as I said, it's nearly from 3.1 to 7.8 centimeters. So these were some of the basic properties of alpha particles, which we have whenever there is a radioactive decay, and these were some of the important properties of these alpha particles. Now let's talk about some of the important properties of beta particles. Now, these beta particles are basically comparable to the fast-moving electrons. Fast-moving electrons. Okay, so we have electron with negative charge, and let's talk about the next important point is that it has negative charge. Okay, and we know it has negative charge, and that is minus 1.6 times 10 to the power of minus 19 coulombs. And the rest mass of this beta particle is equal to the mass of an electron. So mass of electron. So it is 9.1 into 10 to the power of minus 31 kilograms. And they are emitted with velocity. On an average, their velocity is about 2.97 times 10 to the power of 8 meter per second. So they are very fast, close to the speed of light, and they are deflected. They are deflected by electric field, and they are deflected by magnetic fields. And what they cause fluorescence. Like the way alpha particles cause fluorescence, they also cause fluorescence in certain materials like zinc sulfide. And the ionizing power, the ionizing power of these beta particles, it's about 1/100th of it's 1/100th times the ionizing power of gamma rays. So this can be a better way to convey the message here. So their ionizing power is less. It is less than. It's less than. It's less than alpha particles. Okay, so the penetrating power of these beta particles is more than that of alpha particles. They affect similarly the photographic plates as alpha particles does, and alpha particles can travel in air up to many meters. Sorry, beta particles. Now these beta particles can travel in air up to few meters. Now, to end this video, let's have some idea about the properties of gamma rays. Now, what these gamma rays are, they are packets of high energy electromagnetic radiation. Or call them high energy photons, right? And what they have, they don't have any charge, no charge, and they have the relative mass of these gamma rays. The relative mass of gamma rays is zero, and they travel with the speed of light. And that's 3 times 10 to the power of 8 meter per second. And they travel in vacuum with the speed of light, and they're not deflected. They're not deflected by electric or magnetic fields. And what they does, they cause ionization, but their ionizing power is 1/100th of the power ionizing power of beta particles. I think I committed mistake in the previous case when I was talking about beta rays, where I talked about the ionizing power of beta particles. There, I think I said it is 1/100th of gamma particles. There, it should be corrected. It is 1/100th of the alpha particles. For beta particles, the ionizing power is nearly 1/100th of alpha particles, and for gamma particles, the ionizing power is 1/100th of the beta particles. They do affect photographic plate, and they cause fluorescence, but they cause it in very less magnitude. They cause fluorescence. So these are some of the important the basic properties of these particles that come out of these unstable nuclides, and what the additional thing these gamma rays can do, they can trigger a nuclear reaction. They have a capability of triggering a nuclear reaction. And these gamma rays are basically electromagnetic waves. They have all the properties of electromagnetic waves, and frequency of gamma rays is it's large. It's certainly more than that of X-rays. So in our next video, I'll start talking about the laws of radioactive decay, and we would like to do some analytical, classical, mathematical evaluation of decay laws, the radioactive decay laws.